ever wondered how meteorologists measure hurricanes?
How do we know when a hurricane is coming or what the impact will be?
Well, we've got some exciting information for you.
Let's go to the drawing board.
Meteorologists rely on numerical weather prediction to see what the weather is going to look like up to 6 days in advance. The NWP takes into account the butterfly effect and runs many simulations, which is how we get things like percent chance of rain. While these calculations are done on a supercomputer, we can figure out the variables to the differential equations and define them. The Cartesian coordinate system refers to the set of equations used to evaluate the NWP. We measure the change in velocity, pressure, heat, and water vapor mixing ratio over time. By plugging in things like evaporation and gas constants, we can determine the rate at which these factors of weather are changing.
What about knowing where the hurricane will go? Well, meteorologists use equations to figure out the path of hurricanes from their starting points. Here's an equation for example. By using calculus, meteorologists take the rate of change of latitude over the rate of change of longitude, which are both affected by numerous other variables, such as Earth's rotation, the northward and eastward velocity of the hurricane, and others. This equation helps predict a hurricane's trajectory.
So, how do meteorologists find the strength of a hurricane? Meteorologists use calculus through this equation. They find the rate of change of wind acceleration, the Cornelius effect, pressure change gradient to find the strength, and wind resistance. This helps us predict where the hurricane will go and what category it will fall in. The pressure change gradient is the derivative of atmospheric pressure, which follows a slope line formula. The stronger the gradient, the stronger the hurricane will become, and vice versa. Hurricane velocity is determined by taking the derivative of wind fields and is used to find rotation and convergences of a hurricane, helping determine cyclonic development.
A vital part of preparing for the effects of the hurricane is being prepared for the water runoff that comes with it. When predicting storm surge or breached dams, meteorologists use something called shallow water equations. Scientists use this when they want to observe motion on the surface of water, mainly on shallower bodies of water like a lake or the coast. In order to solve, you initially start with 3 differential equations using variables h, height of the wave, u and v, horizontal and vertical velocities, and g, gravity. Then you break down the differential equations into algebraic equations using something called finite differences. The whole process is called transposition. Doing this allows you to make a simulation model, and you can observe how bodies of water will be affected by a hurricane.
Hurricane Sandy was a Category 3 hurricane. In the U.S., it only cost the government $65 million. However, in places where the hurricane hit harder, like Haiti, it cost the government $750 million. Additionally, in Haiti, over 200,000 people were left homeless. While it wasn't the most intense hurricane experienced, the damage was immense. The hurricane cost $65 billion worldwide.
Here's an example of how this looks graphed. Here, this picture graphs Hurricane Sandy's path at various time intervals. Hurricane Sandy had a strange swerve to the west, as we can see here, caused by some of the variables mentioned earlier, such as angular velocity and other changing atmospheric conditions. Mathematical equations help meteorologists track these paths out.
Here, we can see how the National Oceanic and Atmospheric Administration's National Ocean Service Center uses graphs to predict the water levels of Hurricane Sandy. As you can see, the red line is consistently above the blue line, indicating to us that the actual rainfall was greater than the predicted rainfall by roughly the same amount. Mathematical equations and calculus help meteorologists determine waves of rainfall and, in turn, prepare citizens for the catastrophe.
Whether a hurricane is big, like Hurricane Katrina, or small, like Hurricane Sandy, it allows scientists to make better predictions in the future. One of the technologies that is still being developed is the prediction of storm surge, especially with computer modeling. Computer modeling of storm surge can be used for forecasting for evacuations of the coast and response strategies. Meteorologists use the shallow water equations mentioned earlier with models of wave energy and wind.
Math applied to natural disasters helps the public have more awareness and prepare for safety through the national weather broadcast or practice drills.
Thanks to calculus and meteorology, we've developed systems such as the Saffir-Simpson hurricane scale, which allows us to determine how catastrophic a hurricane will be, saving lives in the process.
This data is the difference between evacuating houses and moving to safety or not.
These predictions tell people when to evacuate, where to go, and when to come back to their houses.
Thank you for listening.